Hey there, stargazers! Welcome to the fascinating world of telescopes. Ever wondered how telescopes can see the stars, planets, and galaxies far, far away? These incredible instruments have revolutionized our understanding of the universe. Think of a telescope as a giant, cosmic eye, capable of catching the faintest glimmers of starlight. It's like having a superpower that lets you see across the vastness of space. These faint glimmers are often invisible to the naked eye, but with a telescope, they become clear and detailed. First up, let's talk about lenses and mirrors. These are the core components that make telescopes work. In a refracting telescope, lenses work like the cornea and lens in our eyes. They bend light to focus it into a clear image. Light enters through the objective lens at the front, bends, and focuses to a point. This process is crucial for creating a sharp image. This focused light is then magnified by the eyepiece, much like how our retina processes images. Simple, right? But incredibly effective. Now let's flip the script with reflecting telescopes. These are a bit different but equally fascinating. These bad boys use mirrors instead of lenses. Mirrors can be made much larger than lenses, allowing for greater light collection. Imagine your eye's lens replaced by a shiny mirror. This mirror reflects light to create an image. Light hits the primary mirror, reflects to a secondary mirror, and finally reaches the eyepiece. This design minimizes distortion and maximizes clarity. This design is perfect for capturing faint distant light without the distortion lenses might introduce. But why mirrors? Because they offer several advantages. They're easier to make perfectly than lenses, and they can be much larger. This allows for more precise and detailed observations. Larger mirrors mean more light collection, and more light means seeing fainter objects. This is crucial for deep space observations. Speaking of light collection, telescopes are masters at it. They gather light from distant stars and galaxies, making the invisible visible. Think of them as light buckets. The bigger the bucket, the more light you collect. This is why larger telescopes can see further and more clearly. That's why telescopes like the Hubble Space Telescope feature large mirrors to gather as much precious starlight as possible. This allows them to capture stunning images of distant galaxies and nebulae. So, why does this matter for astronomy? It's all about detail and clarity. The more light a telescope collects, the clearer and more detailed the images. This is essential for studying the universe. This allows astronomers to study celestial objects in great detail. Want to see the rings of Saturn or the surface of Mars? You need a telescope with a big mirror or lens to make those distant details pop. These details help us understand the composition and behavior of these celestial bodies. This is why amateur astronomers and professionals alike invest in powerful telescopes. For stargazing, it opens up a whole new universe. You can see things that are millions of light years away, right from your backyard. Telescopes let us explore craters on the moon, spot distant galaxies, and even track the movements of celestial bodies. It's like having a front row seat to the greatest show off Earth. The wonders of the universe are just a lens or mirror away. So next time you look through a telescope, remember, you're peeking through a giant cosmic eye, collecting ancient light that has traveled millions or even billions of years. This light carries stories from the distant past, waiting to be discovered. It's a direct connection to the vast, beautiful universe out there. Every glance through a telescope is a journey through time and space. Thanks for joining me on this cosmic journey. Keep looking up and clear skies. The universe is waiting for you to explore.